All right, hey guys, JMO here. We're going to be doing part 3, advanced part. It's going to be the first revolved advanced part, and you can see it's a little more complicated than some of the ones we've done before. Not really, but when you get to the next portion, about halfway through this video, we'll see that it can get a little more complicated. And to touch on that with these more advanced parts, it's more commonly going to be make a part, cut a hole in it, something like that, edit it, and then double check your properties, because that's what they do to you in the exam. So trying to kind of mirror all the different things you might see, because really you just want all the tools in your belt, so when you get to the exam, if it's something maybe you haven't gone over or haven't seen yet, you can figure out a way to do it. And that's often, I think, best practice is understanding really what you're doing and being able to apply it in a broad spectrum. So with that, let's look at this revolve. Some of these portions are the whole length, so we're gonna have to cut them in half, so let's think about that. Best way to do this, I believe, would be to draw on the right plane, cut this whole half section out, and just draw that and then revolve it around the straight line there. So with that, we got AB, 1080, brass. Okay, we're going to bust this one out pretty quick because it should be easy. It's the next part that I think will be a little more difficult. Millimeters, manage equations, A, 1000, B, 80. Cool. We're going to be changing the material to brass. My dog is kind of pouting in his kennel right now. He put himself in there and is upset about it. I don't know why he does that. Yeah, you can hear him. Okay, sorry about that, guys. So we're going to draw this kind of profile here. We could put in 100 because we know that's what 200 and a half is, but we could also tell SoildWorks to do that for us. And it's more typing right now, but say you had like a non-obvious number and you didn't want to cut it in half on your head on the fly. Well, there's how you do it. I know this comes out a little bit. I know it comes up a bit, and then it comes over a bit, up a bit. And again, you're just kind of drawing the general profile. You'll get good about seeing the general profile of what you'll have to draw and just kind of doing it. So get used to that and get used to thinking of what you're drawing. I believe the total width of this thing was equal to B. The total height is equal to half of A, right? Because we're still in diameter mode. I guess radius at that point. So this is equal to A, but divided in half. Cool. You can see that got funky quick. With sketches like this, they can get funky quick. Definitely with, with not having all the relations in. So make sure you kind of do the biggest ones first, and then the ones that kind of lock it into shape first, because I think that's the best way to do it. And the last one that's really going to put this one into form is this big boy over here, and that's what I'm talking about with the biggest ones. 890 cut in half. It's like the A divided in half. Those are the biggest ones. I think we know this distance to be 15. And we know this angle, zoom in a little bit, to be 15. Whoa. And then this angle was a bigger one at 45. Okay, I think that's our general shape. Yeah, it looks pretty good. So let's go to revolve this thing. And of course, we're just going to revolve it around this bottom piece. That makes sense. Now let's check that our face is right. So front face, perfect. Top, yep, has the slant, right. With revolves, it's always good to check the 360 just in case you drew on the wrong plane. And quick side note, if you did, you can always, again, go in, edit the sketch plane, and then pick your different plane, and it will change the way it revolved. Now, if you drew this thing backwards, you can draw a line and mirror it, and then unrelate it, and coincident it to the origin, and then change the plane. I hope you followed all that. But there's quick ways to change this whole thing around without having to redraw it all. Now, some people are just quick like me. If it was me, I'd probably just go in, delete everything, close the sketch, maybe not delete it, just close the sketch, open a new sketch, start blasting away with the right context in mind. But some people, prefer to not do that. They've already have a file path saved or something, and they want to keep it, and so whatever you like. But just know that you can still make those changes on the fly if you need to. And on a test, just don't hesitate. Just do it. All right, so let's talk about this next one. The edits to this revolve. Excuse me. You'll see it gets a little more complicated here. Oh, I believe I opened the part for this one that I have. Let's open the sketch. That's my bad, guys. That's the one. Sorry. Okay, here we are. Yeah, it gets a little more complicated. It looks like a completely different part, doesn't it? But kind of sit and break down the differences from the other one, and you can literally just click back question, next question to see the different sketches on the quiz. And you can kind of see the edits they made and why they made them. This one looks complicated at first, but you can see that general profile still there from the beginning, and it's even blown up here, but it's just mirrored now. So that tells me we're just going to mirror that first sketch across that middle line. And this could work for like a flywheel in a car or something, or a machine has like a tapered belt that sits over here and sits in that groove, so it's really nice and tight. And yeah, some holes to cut out material and save weight and all that. Let's pop back over and make some of these edits. First things first, when you're in an exam, we didn't save this one yet, and let's make sure to save it, because you do not want to mess up a part and then realize you didn't have something right and then have to go back and fix it. So we're going to save that. All right, let's do the biggest things first. And I think the biggest thing first is going to be mirroring this along that back edge. So I think a good practice would be to turn this to construction, mirror the entities, grab everything, mirror it about that construction line. That's easy. But we kind of missed something, didn't we? If you guys look at this sketch here, there's this tapered bit, 135 and 100 diameter, and it looks like they went from the same exact corner as before. Yeah, they did. It should be in the drawing, but if it's implied like that, I would go from the same corner. But I'll add that, dimension there just so you guys can see. So let's Control-Z this. We're still going to leave that construction line in there. We're still going to leave this in here, but let's take this and cut it in half. And you can see this midplane would be 50, right? And we're still keeping, in doing that, the relationship to that point. So let's trim off the excess. Oh, I should have kept that. We can still add that. That's not a problem. So we'll go 100 here. And then we'll add our angle. Non-line, there we go. Angle was 135, perfect. And that fully defines it. And we know, because we cut that in half, that portion that they're showing there, this is going to be 50. And we could dimension that here, but we don't need to. It would be over-defined. And now we can grab all of this and mirror it, and now we have everything done, and we don't have to make extra clicks later on. See? Okay, now let's draw on this front plane. This is probably the hardest part of this part, and I've seen this part a part like this. Not to say part too many times, guys. I've seen a design like this multiple times in my classes and on the CSWA and in the book. So someone likes this design, and it's pretty common. You'll see cutouts in a circular pattern into wheels very often. It's to save weight and all that noise, and sometimes provide aerodynamics and all that. So when we look at this, let's kind of break this circle up really fast. Let's put a center line here, so we have some references, and maybe we might not need this one, but let's add one more just so we have it. Okay, so we have some references on our circle now that we're going to draw on. Let's go over to our thing and see what we're working with. Okay, so we have those center lines already. That makes it nice and pretty. It's still just A. We're 12.5 and parallel away from this center line. So we're going to go in and just throw that line in a second. But let's also look at what else we have. We have a circle here, concentric circle of 425 and 150. There's two circles there creating the outside edges of those. So I think adding those in and then this line is a great place to start, because that starts to give us some points where we're going to cross. And then we can add in these angles and the second line, and then it looks like they did the distance from the two, the distance between the two fillets. So we got to add those fillets first to get this line to fully define. So let's pop over there and do that. Oh, I clicked the wrong thing. Excuse me, guys. All right. So we said two concentric circles. This one I think was 150, but that's radius. So we need 150 times 2. Boom, easy. And then the other one I think was 425, and that was a radius too. So we got to do 425 times 2. We said we're going to add this line in. Let's make it parallel or vertical with this one. You can see that. And let's make the distance between the two 12.5. Perfect. We can bring that up a bit in a way, because I like to have it off of the thing. And we knew that it touches those edges and we're going to fillet them. So we can do that. And now let's add that angled line in here because we're going to trim away those circles. So I think this would be the best way to do this. We can grab this and make it coincident just by dragging it around. And we knew it was an angle of 25. We said that earlier. And now we can trim the rest of this junk. We don't need this circle, this circle, this circle. We don't need this line. We don't need this. And we don't need this. Okay, and now it closes in. Cool. And it's not fully defined because we said we need to get those fillets in and we need to get the distance between the two bottom ones in. So let's add all 4 of these fillets. And to get them, you just kind of click each line you're filleting to. I think it was 25. That looks right. We'll double check that. But let's add that distance of 10.75. Perfect. And it rode those 2 lines like we wanted it to. And now we have this nice geometry here that's ready to be cut out. Let's double check all of our numbers though, because we don't want to be wrong on any of these numbers. 12.5, 25, 10.75, 25, 425, 150. Yeah, I think we got all those perfectly. Okay, pop back in the sketch. Just want to make sure all of our things look right. 300, yep, that's 150 times 2. Yep. And then, oh, we don't need these lines here. I didn't see those. And that comes from putting in those extra. I think we could have just put in 1 line and that would have made it real nice. Because that's the only reference we really needed. And we could have just came from up to here. So yeah, just kind of be thinking about those things ahead of time. I erased that outer radius when I did that. So let's add that. 425 times 2. Okay, that's just good practice to confirm everything before you make big changes. So here we're going to extrude cut this. We could pattern that sketch, but I think it's a little bit better to do it in features mode for these circular patterns. Because it knows kind of what you're doing. It'll grab the last thing you just cut. It'll add it in. I do believe it was 8. It didn't say in the drawing, but we can just count. And that looks right. Let's go to the drawing. It should say 8 cut through all, but 1, 2, 3, 4, and then mirrored. Yeah, 8. Let's just take one last long look at this, make sure we got everything right. 890. 160 would have been B times 2. We mirrored that. That's cool. 8 didn't change because it's still the same. We just revolved it. 200's that distance, 100 flat, that's that 50 we thought about. Yep. Okay. Good work, guys. I don't think we made any mistakes, and I think this part came together nicely. Looks really good too. I like the look of this. It's simple and it makes sense. Now, we did mention a couple things. Like there could be a hole in this thing, and that could just be for like a bolt hole, and that'd be a cool little thing to think about. Like, yeah, it'd be like an axle hole. It's not in the sketch or the drawing, so we're not going to put that there, but we talked about it. And you see how quick we can just add a quick hole if you want to, or start changing these parts. You can go in and change this pattern, but everything's fully defined. Everything looks nice. It's to relation in the drawing, and that's really just all we want. So I think we're good to go on this one. Last things last, if you guys want, I'll put all of the, I'm thinking about putting some of the drawings in the description or like in like a Google Drive, and then naming them exactly what the title is and the part name. And then you guys, if you want, you can just go in and download the actual drawings I have. I don't know. We'll see. I might do something like that in the future because it'd be helpful for you guys if you don't even want to watch the videos, which I don't mind at all. You can just pop into the drawings and then check it out. Because I know watching a 15-20 minute video is just, it can't be all the best when you want to just fly through something. I try to go quick, but all right. With all that, we'll wrap it up, guys. I'm going to put the mass properties in the description for part 1 and the part 1 edits that we have here. Last thing I didn't do, which would have been good practice, is to have saved this as an edit. So come in here and save as, but that's something you would do on the exam. We don't need to do that here. All right. We'll talk to you guys. Thank you for checking it out. We'll see you in part 4.